because what you, the unsung heroes in the wastewater industry, do matters. Every Wednesday, join me, Suzanne Chin Taylor, the DooDoo Diva, a longtime veteran of the wastewater, trenchless, and civil infrastructure industry, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. I'll also be speaking with representatives of organizations that are utilizing disruptive or new technologies, and executives who are going to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. So good afternoon, and thank you for joining us on this week's episode of the DooDoo Divas Smells Like Money podcast. We're visiting today with Leticia Eberly, and Letie has had a long and illustrious career in data development tools in our industry for CCTV inspection and analysis. And we got into a conversation about the future of data and what we can do with our data that we collect. You know, cities have years and years and years of a repository of all this data, and maybe they've done some great analysis, they have some reports, they may have even tied it into asset management tools or GIS, but now what? And Letie brought up the subject of, well, I think there's more that could be done or should be done with our data. And so with that said, Letie, share with me, where do you think the power of CCTV data can really go for cities now? And how can they extend it to really help them manage their assets better and more sustainably?
Thanks, Suzanne. Like, to be honest, like you were saying, I've been working in this for years now. And what I've noticed is that the tendency is, when we pass from being a video recording that someone was watching and just call and say, just look at this pipe, it doesn't look good. We move on to the GIS, which now they have the layers, they show on the map, they color code it, but still an individual review of the asset and what to do with it. Some municipalities have gone beyond that and they use it for budgeting and, and what they're going to do next year, but still it's one-on-one basis. It's what happened last year, which pipes or manholes or laterals or whatever the asset is, which one I'm going to review, which one I'm going to inspect, which one I'm going to rehab. What should be done with the data that's collected is what's done in other industries to find out statistics, progressions, deterioration, how is the asset behaving through the history? Not just what happened in the last inspection or just what happened last year. Most municipalities nowadays have years and 10, 20 years of data collected. And thanks to NASSCO, it's collected in a standard. So most of them is standardized enough that you can run. It doesn't have to be sophisticated algorithm. It can be, standard deviations. It can be any kind of algorithm to track and see how that asset has been behaving through times and how fast it's behaving. What can you do with that? You can do two things. One, it can give you an idea of how fast your infrastructure is going bad or how fast your infrastructure is, misbehaving. And the other is it can give you a high level view of what's going to happen in the future. How much money do I need in the future? Not just the 10, 20, 100 pipes that I decided or manholes that I decided I'm going to rehab next year. It's more, okay, what's going on with my city, with my municipality, with my area, and where should I go with it? The same way that we study, like, typical example right now, COVID and COVID infections and, who gets infected. Well, the same thing with the data. We have the data. NASSCO collects hundreds of data points and inspection. And that's something that's very useful. And it hasn't been used as a high level prediction, probability type of analysis to the data. And that's where I think the data should go going forward, not just a video with some pictures.
Right. Well, when you're saying about, nobody can really predict the future, but it's really, it's a
Yep.
crystal ball. It's kind of a rough crystal ball, but more giving you, based on, you were saying, the algorithms, the best case probability or the most likely scenario that you might encounter. And so, is this available now? I mean, is the ability to analyze the data on this level for probability becoming available?
Say yes. Most engineering firms do it. Each engineering firm that municipalities hire have their own engineering staff. And that engineer, based on their training and, and data analysis, that is an per company base, they have created an algorithm in which they recommend to the municipalities what to do. So, some municipalities have the ability to pay these engineering firms to analyze that data and tell them, hey, this is what you should be investing the money. But let's be honest, the United States is made of small municipalities and medium-sized municipalities that sometimes don't have that ability of hiring an engineering firm. So why not have a piece of software that analyzes all that data that you collected and, and tells you, not for 100% accuracy, but it gives you a high level idea of where you should be going or what you should be doing with your infrastructure. We have now billions of dollars to invest in infrastructure thanks to the last bills that got passed. And, they should be a better assessment of where to invest that money than just, I think this is the area that needs it. I think I'm going to rehab this area because the neighbors in that area are the one that make more noise or the ones that pay more taxes, or, I found a hole in the pipe last year. They have the data today. Why not run a software that can tell them what has been happened? This pipe had a hole last year, but 5 years ago, didn't have it. Or 5 years ago, there was a crack, and today that crack is a multiple crack. It shows you that deterioration. And if you have a piece of software that you can customize to whatever parameter the person that works with the assets think is the best fit for them, that's the way they should be going, without having to pay engineering firms to telling exactly the same thing or similar information with the same data, by the way.
Right. So I understand that this is kind of like a pet project of yours, that you were doing this, as I understood, as part of your CCTV data collection software. And then it came to someone's attention that said, wait a minute. Why couldn't this be a standalone piece that could work with basically anybody's software using the PACP standard, and so that cities could get the advantage of this predictive analyzer tool? And so therefore, I love the name of it, the WIKD Analyzer, and I know that's an acronym. So tell me, what does that stand for? I love that term.
Yeah, you're exactly right. So WIKD Analyzer to start is it stands for Water Infrastructure Knowledge Database, and that's what we believe the data is. It's knowledge. All this data that you have collected through the year is actual knowledge sitting there. So, like you said, a few months back, we decided to add, more sophisticated reporting to our existing inspection software, and some of the engineers that we work with and some of the salespeople started looking at it and said, listen, other people can use this even if they don't have your software, because thanks to the standard that the data has been collected on, all these other companies, all the CCTV inspections companies, as if they're certified for NASSCO, have the data on that standard. So the data, is validated and it's accurate as, per the standard. So why not launch an individual tool, a standalone, that they can upload any data from any inspection collected by any company or any municipality, and create a tool that they can tweak and they can use as a dashboard of a thinking board of what's happening. Nowadays, well, in the last 10 years, I would have to say, they've been using the GIS tool as a dashboard. They look at the map and they say, oh, well, this is the areas that we haven't inspected. This area, is red here because of the rating and stuff like that. So we went a step forward with that, because the mapping is only letting you know the PACP rating. And some tools use some of the ratings, others use others, but the rating can be a little bit skewed, and it doesn't work for everyone the same way. And some engineering firms or municipalities decide to tweak it. So we created a tool that they can customize, and they can tweak the algorithm so they can tell what's going on and where. It also interacts with the map, so they can see it in the map if they want to, with the color and stuff like that after they apply the algorithm. But it gives them what we call a health monitor. So basically, it's just a dashboard that tells them, here, this is what's going on with your data. This is what we see the progression of your data is. This is how it's been deteriorating through the times. And it also tells them, it gives them the ability to recommend actions based on that algorithm. So in other words, instead of sitting there through hours of reviewing reports and inspections and videos and pictures, the algorithm goes through all that and tells them, okay, we recommend that you clean this pipe or root cut or grout or rehab or reline it. And that's all customizable. So they can decide what to recommend based on that, on certain parameters. And that's what WIKD Analyzer is.
Well, that takes me to just understanding that difference, because there's a lot of powerful software tools out there that have great analysis reports. So someone who's kind of like new to this concept may think, well, wait a minute, I get all these great analysis reports and I run all this thing. So this just sounds like more reports on top of reports. So what's the difference between what this is going to do for me, maybe a time saver, or just maybe really drilling down on my analysis beyond what I'm already getting with all this reporting that I've been doing and this analysis that I've been studying and working with my consulting engineer for years? Like, basically, I guess I'm thinking, so how's this going to help me?
So yeah, so what's happening today is that someone goes and inspect a pipe or a manhole, and it doesn't have to be the municipality, it can be a consulting firm. And they inspect the pipe, and that generates, if it's an NASSCO standard, generates a PACP rating, a quick rating. There's several grades in there that are given, structural and operational and stuff like that. So each pipe or each manhole is individually graded. What happened after that is that someone, whether a supervisor, an engineer, or someone, sits down and reviews that report that comes out, reviews that report that says that this pipe now is a grade 5 or a grade 4 or a grade 3 or whatever it is, and goes through the list of the defects, right? And looks and see what's going on. So for example, just because it was graded 4, it doesn't mean that it's bad. It might be graded 4 because it has too many roots or too much debris or something like that. But someone individually sits there and goes through all the defects that were found in that pipe to decide whether that's the case or not, right? And what to do with that pipe. And it might put it on a pile like, this is the cleaning, this is a root cutting, and blah, blah, blah. So those are hours of sitting and going through reviews and inspections to decide what to do with each asset that was inspected. It might be done by the municipality or might be done by the consultant firm, engineering firm that was done. So what this software does basically, and it produces tons of reports, like you said. You have reports on top of reports. Every company is going to give you tons of reports, and reports with pictures and reports with grades, and and it's exported in Excel, but still someone needs to sit there and look at the data, right? Still someone needs to look at the 150 pipes that were inspected over the last few months. What this software does, what WIKD Analyzer does, is goes through those defects, those inspections, and decides based on certain parameters that the user can set up at the beginning, when the software is installed, and it's fully customizable at any time. And it goes through all the defects and tells them, like, listen, these pipes are the ones that needs to be cleaned. These ones are the ones that need to re-grout it, and this one's rehab. And there's no need for anyone to sit down and look at all those defects. It's the only thing that needs to be done is import those PACP, MACP, LACP inspections into WIKD Analyzer, hit a button, right? And based on those parameters, the system will issue a set it's one big report basically that gives you a list of all the things that needs to be done with the assets. That's one of the tools that we're given. So that's a time saver over there. So for each pipe, or it will tell them all the tasks that needs to be done. So what's the next step after the inspection, basically, without having to look at the defects, without having to look at video, without having to look at an image. That's for one side. On the other side, we have the other part of the tool is it will basically go through the inspections for each asset, and it will go back historically, and it will look at what's been happening, right? And one of the things that we need to be very careful of is that some of the rating that we're given by NASSCO can be a little bit skewed based on the amount. So in other words, if I found 20 defects that are for root cutting, right? And one defect is a crack, and it's a big crack, my rating might be lower because the root cuttings are more in quantity, right, in that pipe, and they have a lower rating than just a crack. So instead of that pipe being rated a 5, it might end up being rated a 3 because according to the NASSCO algorithm, it's just need root cleaning. Well, our software takes that out of the picture, redoes the algorithm, and basically divides it in two things. What's going on with that pipe or that manhole? Is the inflow being impacted? Or is it the infrastructure and that's being impacted based on what's going on? And it takes away that skew by the amount of defects, and it works on the severity of each defect that was found. And this is all automatically. No one needs to review anything. No one needs to look at it. And based on historic information, it tells the user what's been happening with that asset, how fast it's being deteriorated. For example, if someone has 10 years of history, it can tell you that over the last 10 years, this pipe is having a deterioration of 12%, right? So it can help you predict how that's going on.
Excellent. Now, for those who are only listening into the podcast, you won't get the benefit of this, but for those of you who are tuning in on our video version, Letie has agreed to show us a few screenshots and peek under the hood at some of the really cool things that an analysis tool like the WIKD Analyzer can offer for cities and contractors. So Letie, I'm going to go ahead and share screen with you, and you should have that ability now, and you can take over. And don't have to get into a lot of detail, but I think for something like this, it would be very interesting to see from a visual standpoint how the data goes in and then what they see as our result.
Okay, so what you're seeing right now basically is what the final result is of the WIKD Analyzer. So in this one, it's a small project. And the first thing that the analyzer does is give you a small sample of what's going on with that project. So in this particular case, 10 pipes that were inspected, 2,000 feet, 7 MACP level 1 inspection, 13 level 2. There were no laterals. And there were some acoustic inspections done and stuff like that, right? So this is and 9 pipes that were cleaned. So this is what was done. So this information here is grabbing a project, reading through all the inspection information and collecting what was done during that project. And as the system goes in, here we go. Here it tells you as an overall what's going on with that specific project, how many defects were found by category, and what does out of the project. So imagine that a project is a section of the city or a drainage area. So basically this will tell you what's going on. And, in this case, you have 30% of the defects are problems related to construction. Okay. You have a lot of 81 of the defects that were found. It's just related to operational. That means that root cleaning, debris and stuff like that needs to be done. And you have 94 structural defects that's related to cracks and holes and things like that. So that tells you a high level of what's going on. So here it tells you of all the sections in that area, how many inspections were found by what rating. You also tells you by date, what was done during that project. And I'm just going to move a little bit forward. Here it analyzes all the defects. Remember when we talk about sound and see what type of defects were found? So in this particular case, we found 14 cracks, 4 of them deformed pipes, 10 problems with grout, 9 fractures. So this analyzed all that, and no one touched a single report. They just uploaded the data. Okay. So this is what was found on that particular case. And then we move on to recommendations. So this is what we're talking about. Here's what the system is recommending. So here, for example, for this particular project, the system is recommending that 12.5% of the pipes needs to be cleaned, 8% needs to be lined, 16% of them need a point repair, and so on. 33% is recommending a rehab. And all this, again, these are the parameters that the user set up. And here in the bottom, it tells you the settings that were done by the user and the recommendations here, how many pipes that implies. So, even though clean is 12.5%, it's only 3 pipes they recommended to clean, right? It depends on the size of the project. And this is, again, this is a high level of it. Right. And then as you keep going here, it gives you a list of individual pipes, which ones are. So in this case, point repairs, this one is the other ones that need a point repair. Okay. So this is, just a few pages, and then it moves on to give you individual information on each pipe and each manhole and stuff like that, what needs to be done. And beyond that, if I can go down, it analyzes the connections on the manholes, for example. In this case, the manhole inspection, it tells you, one pipe is green and one is orange. And it basically color codes also the pipe. So this one was graded 5. So each one of them is given a specific rating and stuff like that, based on the algorithm. And it gives you the information as well of the pipe. So it gives you the likelihood of failure. We also use that, and the risk. That's another tool that the analyzer lets you do. And I'm going to close the report and show you a little bit of the desktop of the actual tool. One of the things that is important and hasn't been used, and we didn't talk about it, was that to the field that NASSCO added to the inspections a few years back, and no one is really using, is the risk and the consequence of failure and the likelihood of failure. What does that mean? Consequence of failure is, if this asset, if this pipe or this manhole were to fail today, how is impacting my community? How is affecting the environment? How many people get affected? What population get affected? So if the user, and we're working on adding that to the tool, the analyzer, if the user has some census information in the area that we can tell the impact and the risk of that pipe failing. Right. So instead of, not serving 1,000 houses or 10, that's a big difference on that. So that's a tool that we want to start using, and we want people to know that even though this is a pipe that is a rate 5 and it's only affecting 3 or 4 houses, this other one might be a 5 and it's affecting thousands of people. So that's the thing that we want to start doing with the data. That's the next step where the data should go. What's the impact of this failure? So we use it, and we're incorporating that, and we're trying to see how we can make it easy for the cities, because it's all, one of the other variables that is impacted in there is how expensive is it to replace, right? Is what's the impact, what's the cost, how many people? And that's basically the consequence of failure value and things like that.
So that's getting into
one of the
what
things that I wanted to show you here was a health monitor that we were.
Yeah, just that when you were saying earlier about the prediction, I knew that you were working with some of that, but it's those bottom line benefits, those bottom line costs. And again, the financial impact, could there be fines assessed? If there's compliance issues regarding this, and really, staying ahead, what I call when the government comes in, you don't want them to start adding zeros to the end of that figure. And so this is a way of helping you stay ahead of that curve, so you take care of it before you're looking at not only impact to the community, but a financial impact. And cities are being faced day after day of having to do more with less. The last thing they want to be doing is paying fines that really they get nothing for.
Exactly. And let's be honest, the environmental impact today is important for a lot of people, more people than before. A sewer pipe going into a lagoon, it's not something that's going to be cheap or nice to have, So that's also something. What you're looking here, Suzanne, the screen, where you're looking at the screen right now, this is an asset deterioration analysis. So this is the one that we were talking about. If you look on the right side, it's showing you the progression of this pipe through the years. So we have the first inspection that we have is in 2015. The last one is in 2021. And it's basically showing you that it's progressively getting worse. And if you look on the top, it's telling you that it's deteriorating at a rate of 11.91%, so 12%. Here also, if they decide to, they can select up to, and I believe I have this, up to 4 videos, and they can really if they want to look individual side by side, look at those 4 videos and make a decision, or, do a visual confirmation of what we're showing here of, the last 4 years of inspections or whatever.
Wow.
It also gives you a deterioration chart. And this is what we were talking about, that the type of defect that is found, again, and someone will look at the defects manually nowadays, that's what everyone is doing today, is, it can be divided in 2 cases. How is the flow being impacted? And is there an infiltration? So the analyzer here is telling you basically how those 2 points are being affected on that pipe based on the defects that were found historically. And, if you were to look this today on an ArcGIS map, which is what everyone's doing, the only thing that you will see is basically going back here, you will see a map, and this is the same pipe, historically reviewed, but basically it will tell you, I think, where is it? I'm looking for here we go, the rate index. So basically you will see a pipe here, right? That it was rated at 3. So in the last inspection, well, maybe the year before, because the year before was a 4, they had so many roots, it was rated 4, and this year they clean it, so now it's a 3. Well, that really doesn't tell you what's going on with the asset. That just means that they clean it. But if you're looking at the GIS map today, they will only see a pipe that is rated E, and that's what they color code on the map. So it's really not telling you a picture of what's happening with it. It just tells you what happens with the last inspection. And that depends also on the inspector that did the inspection. I'm very adamant when I train people on this, or when my team trains the operators on this, that I understand that some companies are being hired just to look at the pipe for root cleaning or this and that. But if you see a crack, if you see vermin, if you see something, just put it. It takes nothing just to add the defects on the inspection. And the more defects and more detailed that inspection is, the better this rating is, right? Because it can be misleading. If someone received an inspection rated 3, well, the operator just drew through a crack, and that crack tomorrow can be a sinkhole, So, looking at the history, and especially if the history was done by a different inspector, that will give you a better picture of what's happening with an asset.
Well, Letie, this has been fascinating. I mean, just, data is kind of a boring subject, but you kind of put a spin on it of, we need to be looking at what we have, all this knowledge that we've collected over the years, and how we can make it work harder and smarter for us, so that we can make those truly educated decisions, so that we're not just looking at it and going, wow, this looks like what it should be, or a roll of the dice, so to speak, that, oh, I hope I'm making the right decision based on, one person's interpretation. I mean, I guess it kind of goes back to the original premise behind why we wanted TACP, was to remove the differing opinions of people, to create that standard, because a small crack to one person may be very different than another person.
Exactly. And if you go back to last year, the Department of Transportation, together with the Highway Patrol, which is, I think it's called AASHTO, they created the first inspection manual. That was in we're in 2022 now. So they did it in 2020. So a year and a half, 2 years now. And if you go through the inspection manual, which uses different rating than NASSCO, but if you go through the manual, they repeat quite a few times that it's very important that the asset gets reviewed by a different inspector on the consequent year. That not the same inspector does the same inspection every time. And that tells you what you're just saying. My point of view might be different than your point of view.
All right. And a software like this is just one more layer to remove that human error element. All right.
Yeah, exactly.
Well, I want to thank you for spending all the time with me today and explaining this and giving us the little demo. And if you would share now with our audience, if anybody is interested in seeing a live demo of this or learning more about it, how can they get in touch with you?
Oh, sure. They can go to our website. The website is simply WIKD.com. So simply WIKD.com. And they can reach us over there by email or chat or phone to schedule a demo. We offer 30-day demo installs. They have full functionality. So basically we install it and you can play with it for 30 days. And they can also have the ability to schedule a demo install through the website. So that's probably the easiest one for everyone that is busy today to coordinate when it works for them. I appreciate all your time, Suzanne, and to talk to us.
Yeah, thank you so much. And I'll be keeping an eye on this and watching what's going to be happening next in the world of the WIKD.
Thank you.
Wickedly, yeah, Letie and the wickedly great data.
There you go. Thank you very much.
One of those times where wicked is actually a good thing.
Yeah, exactly.
Thank you, everybody, for joining us, and keep it flowing.
Thank you.
Thanks for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. Be sure to subscribe to the show so you'll never miss an episode. And while you're at it, if you found value in this show, we'd appreciate a rating on iTunes, or simply tell a friend about the show, because that would help us out a lot too. If you're an industry expert and would like to be considered as a guest for the show, email guest@smellslikemonymedia.com. Tell us a little bit about yourself and the topics you'd like to talk about, and we'll be in touch. For more information about our family of marketing, international business development, and workforce training companies dedicated to the empowerment and education of our industry, call us at 760-217-8010 or email me at raven@creativeraven.com. Until next week, a big shout out to all my industry friends and those who will be. You're my superheroes.